Здравствуйте. Long time no see. Well, yeah, it's a long time. I think it's already been for about half a month, but... hi, Hanshel, and hi, David. I think it's been about... well, half a month, but to me it's like... well, if you're really feeling about something, you can just feel like the time is literally flying, because... for me, it's more likely... wait, how many times are we going to... how many times am I going to talk about, like, likely to, probably... I still remember, like, last stream is just a few moments ago, but it's just, it's half a month, 2 weeks. It's a long time. Yeah, seriously, it's a long time. But I can't feel it's too weak. That's the problem. 为什么这个 BGM 听起来老人味这么重？其实已经很久没有听到自己的代替 BGM 了。不过听说是比较那个什么来着？比较安定的一首 BGM 大概吧。我可以说小可以讲就。well, English and Chinese are both okay for this channel, so I'll just probably switch between two different languages. It depends on the chat room, so feel free to use what you want to say. And, well, alright, so what should we do? For my original plan, I just want to play Carol Space Program, but, well, I'm suffering for some issues currently. The midterm, so, yeah, to be honest, it's like the topic of this live stream is talking about a space environment and hazard, and how do we deal with it, but it is actually what I need to read because I have midterm next week, so let's deal with it, huh? Well, it depends. Wait. Okay. So, well, I'm not quite sure what kind of way am I going to explain it. I can stay in this section. You can see, well, I'm just literally in an old-fashioned space station. Or I can just switch to another, the old live gaming room and turn on Kerbal Space Program and tell you like how Jeb is going to die. I think it's going to be it's going to be more interesting. And well, there's no background music in this scene because normally we have Kerbal Space Program's music, and literally it is like you can hear the rocket engine are screaming, and the vessel is exploding, and those cannons are again screaming like that. So. Where shall we start? 我们从哪里开始啊？先把卡就要开起来好了。可是这样子感觉又比较不像杂谈，还是说我们应该，再切回来好了，先切回来。这样聊一下，还有就是背景是真的该换了，不知道有没有什么比较好的背景图，就其实也不太有时间找。如果有人可以给一点建议的话，就拜托了，因为。真的这边是缺乏装修，我真的是完全缺乏装修啊。快开始了对，基本上卡巴计划都是有一个，我们都要设计一个任务嘛，就是有在正常模式下有合约，不过基本上大家都会有一个比较明确的任务表，像是我们要去月球啊，去 Moon 啊，去 Luna 去 U 啊之类的地方。那这些任务在具体上要怎么设计呢？How do we exactly design the space program in the real life? That's what we're going to talk about today. Like in Kerbal Space Program, we Normally, we just say, okay, we want to go where? Okay, so we check the Delta V map and design a vessel which is supposedly can get there and send the crew back safely. But, well, the reality, the real world don't have the safe load trick, so it's not going to work like this. So I'm not just going to discuss about the full mission design process of a space program. There's going to be 8 phase. Yeah, 8 phase. So 大家看你的这样子，在这个地方讲话不会觉得无聊吧？就首先呢，we need to the first step we need to do is define mission objective. Yeah, define mission objective 就是我们要去决定任务的那个，要去对任务一个最基本的定义这样子。所以在这个 phase 里面呢，我们会基本上去定义说那个有什么非常强烈一定要达到的目标。像是那个如果是阿波罗计划 ，if we are talking about the Apollo program, the mission objective is literally send human or man because there's no female used to be on the moon, so the objective is send men to the moon and back safely. Yeah, safely. That's a common mission objective. So yeah. Where shall I need to open some materials. And where are them? Oh, here it is. So once we know the mission objective, the next step is like how could we exactly to design a mission more clearly? 就是说，如果我们决定了一个任务的主要目标，就是最基本的那几项目标之后，我们要怎么去更比较细致的去定义说这个任务目标。So the next step is define mission requirement and constraint， 就是说这个任务有什么需求，跟它有什么限制。那个基本上 basically the requirement types can be divided as like functional. I mean, it means what do we need? Yeah, functional. Like if you want to send astronauts to the orbit, you need a spacecraft that's functional. You need a capsule or a vessel that has a function of a spacecraft. And another is operational. It means how. I mean, how do you operate it? Like, well, there are different ways to send a spacecraft to the space or the orbit, right? Like the space elevator, or probably, a cannon, if the crew can survive, or rocket. Well, apparently we only have rocket now, so it's like how. 那也有别的东西啊，就是像是那种，举个例子好了，就是如果是登月 ，if we're talking about go to the moon, and we are talking about requirement, like it's about how we go to the moon. 那基本上如果对登月计划比较了解，就可以知道，就是当时美国跟苏联都分别设计了好几套方案。然后另外一个就是那个performance， 就是我们对这个东西有什么性能上的需要。例如说，如果我们要把太空人射到轨道上，我们就需要有一个能够把他们送到轨道上的火箭嘛，这就是那个 performance， 你火箭的 performance 要够这样子。然后另外一个就是 constraint， 我们有什么 limit？ 那这个 limit 就是说，可能是 cost 啊，可能是预算啊，也有可能是那个 schedule 啊，我们要在几年之内把人送上去，不然我们会被一些奇怪的势力抢先，这样的宣传不好啊。再就是 tech， 所以就是这些 constraint 基本上如果我们在玩坎巴的话，在生涯模式下也会遇到的。第二年因为手感不好，怒砸耳机卸油器，什么意思啊？什么意思？ Curve man, where are you running? Okay, so 基本上这个在这个步骤 in this phase we need to design brief mission, and this is how the design decision guidelines come. So we are talking about requirements. It is about how we must do in the space mission, and another is constraint. What do we must not do in the space in the mission? And we need some ground rules. So it's about the limitary space. Normally it should be consumer specified, and another is assumptions. It is by designers. 所以这基本上第一步前面说的第一步就是我们需要做一个比较精简的任务设计。那任务设计之后，我们下一步就是要去进一步的去细化说，如果要完成这个很笼统的任务目标，基本上就蛮笼统的嘛。但是我们要去火星，对，登陆火星是一个很明确的目标，但是它也蛮笼统的，就只是我们知道登陆火星，但是我们不知道要怎么去。那下一步就是说，我们要去确认任务的一些细节，就是它最基本的要求。那基本上这些要求就是有，我们有什么是需要做的 requirement， 跟不能做的 constraint。像那个太空任务有一个 constraint， 就是我们不能够让主人死掉嘛。虽然在坎巴拉太空计划里面，太空人都会原地复活，也要看难度啦。然后再来就是 ground rule 跟 assumption， 所以 requirement 跟 constraint 这几个就是没有讨价还价的空间。requirement we must send a crew to the moon, to Mars, or to space, whatever. That's we must do. There's no space for discussing. We need to do it. And the constraint is what we must not do. Like, we can't lose our crew, or mission failed, or it's like the rover on the Mars need to be worked, or mission failed. It's constraint. Or probably it's like, okay, we are going to use like 400 rocket launch to assemble a gigantic starship in the orbit. That's probably a constraint, probably. And then we need ground rules, and those ground rules are normally consumer specified. These are like trade space. So 在 ground rule 的部分，你就可以跟别人讨价还价，就是说我是要带样本回来我是要带50公斤的样本还是100公斤的样本，这些是可以讨价还价的。然后通常这些都是customer， 抱歉讲错 ，sorry for my pronunciation. It's not consumer, it's customer. So normally it is 一般来说这些都是甲方决定的啦，就是这些ground rule都是甲方决定的。然后再来就是 assumption 基本上就是你自己要对这些任务做一些假設，就是 this is by designer. Yeah, it's by designer. So if you're a designer, you need to make some assumption to check about to 就有一些不明朗的部分，你得自己想办法去做假设，因为它就是不明朗，你也只能自己挑一个方向继续走。然后嘛，this is phase 2, and phase 3 is develop alternate concepts and architectures. So we have, we know the mission, what the mission is going to do, and we know that what is basic limit and requirement and ground rule and assumption. So we have these like rules. So under these rules, we need to develop several concepts or architectures, like how things will generally work and how things will generally fit together. And it should be alternated, because under these rules, normally it's not about we are thinking one solution. It is about we are brainstorming to find multiple solutions and try to pick up one best. It is engineering, you know. It is engineering, and engineering is about compromise. So this is how this phase is going to do. And well, we're going to compare different mission concepts, mission by mission, by those pros and cons, multiple ways like cost and benefits. 所以还是回到那个去月球的部分哦，就是说 ，Well, let's drag back to the mission of sending a man to the moon. So, as Ted said, TKS and 钱洛梅，就是说，当然有很多不同的方案，像是当时如果对这个方面有研究的人，应该就知道是阿波罗计划采用的是在轨组装，然后去月球之后分离的方案。当时也有很多不同的方案，像是整个太空舱直接降到月球，然后在整个太空舱一起起飞。但是因为这样太空舱比较重，所以就需要在轨组装，就是有很多不同的方案。那为什么最后选的这些东西，一定是有它的妥协在的。所以到它的第3部曲就是尽量的去想一些不同的概念，然后去进行比较这样子。So here we're talking about concept and architectures, and mission architecture is a combination of mission concept and element options. 当然，这个地方就是我们在设计 mission 的时候，可以有两种不同的方案。我们可以从 top down， 也可以从 bottom up。那 top down 就是我们从任务的导向去想说，就是它是一个goal driven. Top down process is like a goal driven process. It's about okay, we need to achieve this goal. So what should we do? Let's think about it. And for bottom up, it is like it is tech enabled. We are picking up the usable tech and try to assemble those tech into an operable mission. 其实这两个方案就是看个人喜好，也都有人用的像还是用卡巴当例子好了，就是如果我们是在玩，不能用什么模式来分。如果我们在生涯模式做任务那我们的 top down 就是甲方的目标。甲方今天叫你去盖太空站，你就去盖太空站，那你就需要有一个 top down 的思维。我要完成甲方的要求，那我要怎么跟甲方斗智斗勇呢？这是一个 top down 的思维。那 bottom up 就是说，我今天要去月球是没错但是我手上目前的资金跟零件可以 support 我到多远的地方，这样子能够做出多大的船，这就是一个比较 bottom up 的思维。Okay, so we have different mission concepts. This is phase 3, and we're talking about phase 4. And this time we need to identify critical system drivers. 就是我们现在有了不同的任务。那这些不同的任务，我们挑了几个喜欢的之后，我们就要开始。因为任务是很粗浅的，就只是知道我们要去哪里干嘛，我们要怎么做，我们要做什么以及怎么做，但是我们还不知道我们要怎么样去做这些事情。So the fourth step is identify critical system drivers. And here's what is system driver. Well, system driver is about its parameters significantly influence. 他们是比较注重一些参数的 ，including cost, mass, performance, risk, schedule, anything you can imagine. So we are actually thinking about what things do we need to achieve. Hey, Mass Critical Man. Hello, I don't see. Yeah, it's a long time. It's about half a month. But as I mentioned before, I can still remember like the last time I streaming was like, well, the local time I am was Sunday morning, and it's just a few moments ago. I can't feel it's 2 weeks. Time passed so fast. I mean, probably I want to do some live stream during normal days, like Monday to Friday, but the issue is, like, here is GMT minus 6. Here is GMT minus 6. So I'm afraid that if I do live stream in the local time GMT minus 6, it is going to be a weird time for others Because, like, Ch.-6 here, if I do live stream in this time, it's going to be, let me think. Morning, yeah, normal day morning. Like, try to imagine like I do live stream on like Tuesday morning. It's incredible, yeah, incredible. Taylor一直和我吐槽，全世界都在用阿波罗式登月，没有新意。那怎么说呢？你们要不要去看一下现在一些新创公司回收火箭的方式？就大家都在摸着石头过河啦。那基本上一旦有一个方式成功之后，它本来是一个验证过的方式。那照了这个路，它的风险确实也比较小。那你也只能在风险跟创新之间做出权衡啦。那该怎么说呢？就创新是好事，但是它有风险的，而不是很多人都能够承担得起这个风险，特别是对一些没有政府支持的公司而言，他们没有那么多的试错机会，他们自然就只能选择比较稳妥的方案这样子，这也是妥协啦。别人希望就是大家都要创新啊，可是要恰饭的嘛，薪水要发的嘛，老板不能跑路嘛，所以还是只能做出这样子的妥协，真的是蛮呕的。Well, that's just my mumbling. Well, sorry if you wanna understand what I'm talking about, or I mean interacting with others, you can just ask in a chat group. What sounds like a teacher or professor? I don't know if you act like that. Sorry. It's just a casual chatting. So let's go back to prepare like a PPT or some picture to be a support of this lecture. No, chat, but I have no time. Well, really sorry about that. Probably I can edit in the future. Probably if I have time. Seriously. So we're talking about identify critical system drivers. And system driver is what system do we actually need in the mission we designed. So these mission drivers are including like, well, let me give some example like crew number, how many human or dogs or monkeys are we going to send to the space, and habitable volume, how big is the space station or the spacecraft going to be, and like Eclipse, I mean the environment control and life support system. What is the system going to be used? What kind of resource? We need oxygen. We need to deal with wastewater, or like what kind of opposed piece? What human exhausts CO2, that kind of stuff. This is a system needs to be dealt with, and what kind of subsystem we are going to need. It's like. Okay, we need to communicate with the Earth, so we need a communication system. And if you're a designer, you're gonna like, okay, we need a communication system, and you don't know what it looks like, but you can just deal with it. Okay, here is a subsystem. Here is the communication subsystem team, and they are going to design a communication subsystem, and they will tell you how many power it's going to cost. Or like how big it is, how heavy it is, how far it's going to work, like that. You need to separate it to different subsystems, or like data rate, how soon are you going to launch it, or probably some Apple Empire, whatever, probably it's going to be number one. That's going to be a problem. And number of launch, or like spacecraft launch. How many launch are you going to build the exact spacecraft? Normally it should be one, including a lot of like probes or satellite rovers. The space station needs multiple launches, so it is another thingy to deal with. These are like system drivers. And of course, power and propulsion, like the Nakwa, 这是 pronounce 科学号的发音是这个吗？科学号的发音是这个吗？应该是吧。就它也需要自己的推进系统啊，不然它没办法，没办法把它推到国际上的高度啊，它只能自己摸上去啊，这样子。这就是那个tech level 啊，对啊，我们想说，要是我们有太空电梯，我们要盖太空站，就叫太空电梯拉上去就好啦。可是我们没有太空电梯，所以我们不能这样设计。再就是 schedule and opportunity. Opportunity is about like the launch window. 举例来说好了，就是如果下一次去火星的窗口是在2年后，应该在2年后。可是你现在盖一个火星车需要3年，那这就是一个问题。Well, this is a problem that normally we are going to deal with in a game called Mars Horizon, but I hate this game. Seriously, Mars Horizon is a nightmare for me. Seriously, if you watch the last live stream about Mars Horizon, okay, 贝佐斯我的引擎呢 ，Vulcan 应该也快要飞了啦，希望是这个样子啦，希望。现在真的是可以再比了。我觉得 James Webb 应该是可以如期升空，只是 James Webb 可以如期升空。现在在比的应该就是我们可以来看看科学号已经上去了，我们可以来看看那个 Starliner 跟 Vulcan 什么时候哪一个会先上去。说不定安家都上去了，然后他们都还没上去，有这个可能性的。So the phase 5 is select baseline mission. And we are dealing with the requirement of the mission, and we define several concepts of the mission, and we find what kind of subsystem or do we need in this mission. So this is the time we need to select the baseline mission. And this is the time we need to really dig into the detail of the space mission. And this is like what a high-level mission concept is going to work. We have like concepts and off-con. I'll explain it. So when we are just discussing the baseline mission, I'll still use the moon mission as a reference because well it's classic and typical. So or probably it is just because it is all my materials. Sorry. And okay, we used to be like design several concepts to go to the moon, like the Apollo style, the Soyuz style. Yeah, Soyuz used to be the vessel that sent cosmonauts to the moon. That's why we have Soyuz. I think it's Soyuz 4 and 5. They dock with each other and exchange the crew because in Soviet moon program, astronauts needs to EVA to the moon lander. That's one reason. And we deal with several mission concepts, but those are just like a glance. Like if we choose to land the whole things on the moon, it is just in this phase. In phase 3, I mean. But in phase 5, we really need to deal with the detail of the mission. It's not about okay. In phase 3, the concept is like okay, let's land a vessel on the moon surface, and in phase 5, we need to start to think about what is going to happen when we are landing a vessel on the moon. So first, we need to think about the concept of operation. It's about concepts. Yeah, concepts. So it gives us a general view of the overall picture of the operating a mission, and it used to derive needs and requirement。就是说，基本上我们就是需要把一个任务的流程，完整的先想出来。就像在坎巴太空计划，就是说，如果我今天要去做一个 Geo5，yeah Geo5 is really satellite now. I just don't know. I just don't know when will I have time to complete my I really don't know when will I have time to complete the Geo5 mission. But in Geo5 mission, that's a pretty challenging mission in Kerbal Space Program, of course. So if trying to imagine like you are thinking about the Geo5 mission, and you need to think about the concept of operation. So you need to deal with like, okay, first I need to use 3 launch to assemble a vessel in the low carbon orbit, and then use several gravity assist passing EVA once, carbon once, and Eve twice to go to Jewel, and then vessel A separate with vessel B, okay, and land and launch again. So we are discussing the whole operation details. We're actually discussing the whole details of the mission. It is concept of operation. So literally, we do this because we want to know what is going to happen on any step of the mission. And then we need to design reference mission and like capture all mission operational phase， 就是说我们设计一个概念任务，然后那个我们先反正就是这2步，就是把一个完整的太空任务先在脑袋里演练一遍，这样子。这件事情其实很常做，因为它成本比较低嘛。像是那个之前已经下完了那个星座项目也是这样子。So we have concept of operation. It gives us a glance of the mission, and then we need to think about the operational concept. I mean, OpCos. And operational concept gives overall picture of the operations using one or more specific systems, and it is going to describe how a particular system will be operated to satisfy the needs. Well, it is definitely not a requirement stock, but it can describe system operational intent, and it actually derives needs and requirements. 外面是不是有警车声音啊？应该没事啦，应该没事。我讲这个不会被跨国吧？不会，我讲这个不会被跨国吧？应该不会吧？他应该不是来招回了吧？应该不是吧？应该不是吧？先顾去 SSD 哦，请好哦。看秀，你心理上好不好？你心理上。So, sorry. I mean, I know that today's live stream is going to be a little bit bored. It's all talking about things, and probably, I don't know. Probably a lot of audience don't know what I'm talking about. So that's going to be a problem. A live stream definitely is not going to be the best way to deal with it. But I mean, yeah, if you don't know anything about, but at least know what word I'm talking about or I'm speaking, still feel free to ask question or like chat with me. Okay, so OpsCon. Comparing concepts and outcomes, it is like, okay, we design a visual mission in concepts, and now in outcomes, we need to deal with what exact system are we going to use in each phase of the mission. So it's like, okay, still talking about go to the moon. It have different phases, like docking with the moon lander, transfer to the moon, and moon landing, moon ascent. And these are in concepts. And in OpsCons, we can discuss about like what things are we going to use during the docking phase. Like, okay, we are docking, so it is, well, which docking to what? We're going to use autopilot or let the astronauts control the vessel. 所以就是说，如果是在那个 concepts 里面，我们讨论的是这个任务每一步在干嘛。那到了 OpsCon 的时候，我们就会讨论的东西是，在这个任务的每一步，我们分别要让什么东西进来做事。像 OK， 如果是月球任务，可能我们要在地球上对接，然后对接到那边，然后再分离，然后再下降。那到了 OpsCon 的时候，我们就会讨论是什么跟什么对接，是那个指挥上转过去，还是那个登月小艇自己跑出来，然后转180度绕到前面去。这些都是需要考虑的这样子。Okay, phase 6, we need to define systems requirement. Okay, it's finally here. So, in phase 1 and 2, we discuss about what's our main goal and what are the limit and the requirement of the mission. And in phase 3, we design several concepts. And in phase 4, we discuss about what kind of subsystem or we need and what's the parameter we need. And in phase 5, we pick up one solution to create a virtual mission and discuss about what kind of things do we need in each step of the mission. And finally, we are here, step 6. We know what is the mission going to be, what we need in the mission. So here we are actually not specify. It's we are actually clarifying the system requirement. 因为之前我们都在讨论说我们需要什么系统啊，这系统是拿来干嘛的啊？现在确定了之后，就会变成说我们要这些系统具体来说到底要干嘛？所以我们需要去制定说每个 subsystem 需要干嘛，就是我们 we need to characterizing subsystem. It really looks like a lecture. Oh, I'm so sorry. Probably it's very boring. Or probably everybody just watching me exploding, like a rocket exploding, or suffering with cracking and screaming and yelling. 你为什么都没有做？认认真真的做航太是不是没有前途啊？Okay, so talking about characterizing subsystem, we need to like make sure like overall vehicle configuration, the base structure, the ethos, the environment control and life support system, and the crew and the payloads accommodations. And wait, what is accommodation? Is it accommodation? Okay, just Google it. Accommodation. Let's see. Where is it? Oh, it's like where do we store it? Okay. Now we need EVA system if we want the astronaut to go outside. Do we need spacesuit? And do we need airlock? How about rovers? And do we need tools to repair probably those things? And we also need avionic avionic, like GNC guidance and control, or like attitude, attitude design. Wait, it's not design. ADCS. I just call it ADCS now. It's about controlling the attitude. It's ADCS. Okay. And the power. Yeah. It's about numbers now. It's like, what is the average power we are going to coast? What is the highest and the lowest? I mean, the peak, and the circuit, the voltage, the watts, and the mass. Of course, it's because we can't let it too heavy, or it's going to be very expensive. And the propulsion, the RCS system, and now we need to integrate as much as possible, because more complicated means more risk. So we need to integrate several systems to and calculate about total mass and volume. Okay, and things are almost done in phase 6. Yeah, almost done in phase 6. And 那前6部其实把事情都做完了。那第7部 in phase 7, we need to dig into the document trace and rational. Normally we just search from the past mission and avoiding remaking the wheels. I mean, every decision have its meaning. I wouldn't say every decision is rational. I often do some decision just by my mind without deeply thinking. So it's basically a lecture. Design principles are important to learn. Thanks, Matsui. Thanks. I mean, yeah, thanks. Well, probably it's a wrong decision. Like, okay, I make a decision to talk about the design process, but is it really a rational decision? Probably. Oh, you guys, marbles, or I call me Ch.美空this is my fan name. Probably all marbles just wanna me looking at me, exploding vessels and those Kerman dies miserably. That's everyone want to talk about. So it is not a rational decision. But I mean, every decision has its own meaning. No matter it is about your mind or science or even politics. And that's why we need to search back into the past mission to avoid making wrong decision. I mean, it's a reference from the past. And I think it also answers the question that Hanshil mentioned. He said that a lot of people are using the old-fashioned way to go to the moon, like Apple style, and it's not about innovation. But hey, well, I mean, sometimes engineering is traditional, or sometimes it's full of innovation. It depends. It depends is an important word. A lot of questions doesn't have answers. It depends. So far you are in phase 8. Integrate and iterate. And I think the name of this phase answers a lot. One is integrate, one is iterate. So you need to put all the things together. 因为我们前面想了任务的细节，然后又想了任务需要哪些系统，然后又分别量身定做了这些系统。那现在是时候把所有东西全部都在一起了。It feels like, okay, you finally designed a full mission. Now you are building things. So you are in VAB, in carbon-based program. So you're actually adding components to each other. That's the things you need to do here. integrate and iterate. Can you use one thing to do multiple things, so it's not going to be that complicated? We're talking about verification and validation. It's like, do you build the thing right? And do you build the right thing? Like, okay, you're going to design a rover, but you only add one wheel to like pray it's going to be self-balanced. It's not going to work. And it's about build the things right. And about build the right thing, it's like, okay, you need a vessel, but you actually build a helicopter. That's not the right thing. And then define the life cycle. It's quite interesting. Probable and explosive are the same thing. No! Actually, no! I would say it depends. Yeah, it depends. 就蛮神奇的一点是，到现在才需要去决定说这个 life cycle 的部分。life cycle 跟 logistic 就是你要去确定说每一个零件它们是不是有自己的 life cycle。那如果要有 life cycle 的话，你是不是就需要做一些 backup 的处理？你要怎么确保这些东西在任务中不会出问题？如果出了问题，你要怎么负责？那到了这一步，基本上就是你去想啊，如果有问题的话，就更新你的设计。这也是为什么这边会有一个迭代，就是iterate 这个字代，因为你要去 integrate and iterate. You need to consider about the life cycle and the logistic. Is a thing going to be unfunctional during the mission? And if that happens, do you have backup system? If not, you need to make sure the risk is low enough that you can bet. Like, okay, during the space race, we only have like 50% probability to success to send the man in the moon, but it's Cold War and we want to be number one, so it's tolerable. And also you need to consider about what's that? Consider subsystem compatibilities. What is it? How do you explain? How do I explain it? How do I? Oh, yeah, compatibility. It's about you have a lot of subsystem, and these subsystem need to interact with each other. So you need to make sure they can interact with each other. Yep. Well, I think very classic example of subsystem compatibility is Apple 13. Everyone should watch that movie. Seriously, it's a nice movie. It's a nice movie. 所以我说我们在这一步是要考虑到系统兼容性的。那系统兼容性不好会有什么后果？大家看阿波罗13应该就知道了。Yeah, it's about the design process, and it take not bad, 50 minutes. 50 minutes is about like one lecture or one class. Well, it's definitely a lecture now. So I apologize for the boring part, and let's discuss like how Jeb is going to die in space. Okay, Kerbal Space Program time. Well, I still have some things to do. I just don't know what I'm going to do, so let's deal with it. And I'll probably just play the game and discuss about space environment and hazard. That's the topic. Yeah. I don't want it to be like a lecture, but I have no choice. Sorry. Alright, loading time. MacJab. Yeah, these nodes are incompatible with Kerbal Space Program 1.12.2, of course. Yeah, subsystem compatibility. So, what are we going to discuss? 我们接下来谈什么 Yeah, space environment and other 太空环境中的危害。危害。So, why I choose the topic of this live stream as beyond Kerbal Space Program? Because this is a thing that not included in in Kerbal Space Program. Well, during this loading, let's just discuss what is hazard in space. So first, we need to clarify the definition. It is very important in an engineering field. What is okay. Physics. Come on. Da 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 da. Da, 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 da. It's still loading. Why? Okay. Can you lower my... Oh, it's a little too loud. Okay. I think the volume is fine. Yeah, the volume is fine. And start game. So first, let's look at this happy floating Carmen. And what is hazard? Well, normally, by definition, my friend made a model of the Falcon X in case you like Falcon X. Falcon 9, it's Falcon 10 probably, Falcon 10. So I figured you can do anything in it, but how much do you think you would benefit from a space elevator if you decide to implement one? Well, for me, in my opinion, the first thing is, how could we build an elevator? Because we need to identify the question. It's like, well, try to image that. David, do you like me to just call you David or Louis? Alright, I'll just call you David. Your question is like, try to image that. How much do you think you would benefit from making a hover car if you can make it? Or hover skateboard. Well, I love the movie Back to the Future. So yeah, like how much do you think you would benefit from building a hover car? Well, the first question is we don't have a hover car, so it's not a question. So I think the first question is about how could we build a space elevator? Is it feasible? What kind of material do we need? And how many launches are we going to? Is it going to cost in order to build a space elevator? And where do we place it? And after all these things is solved, we can start to discuss how much will we benefit building a space elevator. Because it is feasible, so we can still consider about it. I mean, if it's too expensive and it seems like we're not going to benefit much, we can choose not to build it. But the truth is we can't build it. Yep. Does that make sense? Hopefully. Yeah, hopefully. So let's get into reason saved. Okay. So what is hazard? Back to our question. What is hazard? And hazard is a potential of harm. Potential. So normally these potential are dormant. These harm. Sorry. So hazard is the potential for harm. Normally these harm are dormant or potential. Normally, but once any one alarm become active, it will cause emergency. That makes sense? So the hazard and the possibility of the hazard, we call it risk. So what is a risk in the space environment? Okay, so the time says that Lunar Lander 2 relay is time to go. So let's see. PY space elevator would reduce your options in KSP, like how are we going to go to space today? Take an elevator. Tomorrow, same, and next day, and next. Yeah, that makes sense. But the truth is, yeah, some person will say, oh, did you see that movie? In the future, we are going to use space elevators. So why are you still learning about rockets? Well, because we don't have space elevator today. And if we want to build a space elevator, we need one. That's a problem. So it says that the Lunar Lander relay is here. And let's see. It seems like I need to send them back to Kerbin. Okay, so here is the... Hey, what? What the heck can it be? It should be... this stage is already here for a long while, but it says that the solar panel is... yeah. I don't know why it happens. So... I think the one on Ike is too, so... yeah, but this relay... Hey, manager, Yue, hey, good night, good evening, good morning, what should I say? Let's go back to... Space elevator! Yeah, it's Combat 7. I love that space elevator, but unfortunately we can only... Oh, look at these. Space. We are discussing about the space environment and hazards. So it's the correct way for me to discuss about it. And the problem is... Okay, let's make a decision. I have a ground habitat on lunar surface. It is a window for sending these crewmen back to Kerbin. Shall I send them back? Shall I? I don't know. Shall I? So this is the accent stage. Okay. Nobody is here, so it's lost its control. Is it sliding? It? Yeah, I'm sliding. And how about... Okay, so... not this one. Not this one. Not this one. Here it is. I have 3 crew here in this habitat, and I'm not sure if I need to bring them back to Kerbin. I don't know. I really don't know. Should I? Or shouldn't I? Alright. I'll deal with it probably next time. So... Alright. Let's start from... Seriously, let's start from Kerbin. Or, Earth. So there's a lot of stuff. Let's just go back to the Space Center. And consider about, do you have any crew in low Kerbin orbit? I don't know. It's a long time it's already a long time since I started to play Kerbal Space Program, but yep. Let's see. No. Wow, that's interesting. I mean, I have a lot of vessels, but only few of them. I mean, there's no Kerbal. There's no carbon on the low carbon orbit. It's weird. Freaking weird. So let's see if we have any kind of mission we can take. And repair the line. Do not today. Recover. Oh yeah, recover. Yep. What is it? Okay, building a new outpost. That would be nice, but hey, rescuing. Recover. Mabry scrap from the orbit of Moon. That sounds nice. So let's do it and talk about the space environment. Well, it's 1.8 tons. It's a little bit heavy. Carbon orbit around the sun. Dang it! What I do now? Okay, I'm not going to take it. I'm not going to take it. Build a new. No. Let's see. I'll just send a vessel to the low carbon orbit and let's deal with it. I can first launch a vessel to a low carbon orbit and. Alright, let's see what is going to happen. To Gouda. Hey Gouda. Should I say up? I cannot like I'm not as talented as Gouda. So sometimes I'm a little bit kind of jealous because well as an engineer it is really I want to be an engineer and sometimes it is like well yeah I'm on my rail to become an engineer but well there's a lot of sacrifice I made to become a engineer and that's a problem because I'm not as talentful as others. Well, not this one. So what am I going to use? This one? Okay, let's just deal with this one. But this one is not quite. Alright, I'll build another one. I'll build another one. I'll probably have to use Space Shadow. Alright, let's look at this neat Space Shadow. It's not going to have a lot of good hobby, that's a problem. And also, another season is we're going to dock and pick up another thing, so. Alright, deal with it. I still prefer the classic way. So. Let's see. Just add, well, why not? Okay, asking about Anakin. And we have 7. The Dobby should be okay. Yeah, it should be okay. And alright, let's go. Well, I still prefer a neat way to do slime because it's just a cylinder. I don't like it. Nah, it seems like we don't have any choice. We still don't have any choice, so okay. I need another launch to grab it back. Currently I just call it A. It's ugly. I have no choice, seriously. Okay, so launch. You wanna use like watch out 2? Like the Vettelyanov take to explain what's a hazard. Alright, to be honest, let's do it. I'll just use. Let's build a watch out to the moon. Okay, let's build a watch out. Back. Let's build a watch out from an empty UAV. 哎，冰雨晚安。刚好现在是个游戏比较无聊的部分，本来这个游戏有趣过嘛？好像只有火箭爆炸的时候，可是火箭爆炸100次好像就不怎么有趣了。啊，漏的我们 OK 啦。这个东西有点太那个，所以就 whatever， 我们重新设计好了，我们只要扔2个人就行了，所以不用再太多人。先装2个人吧。crew OK。我还是想做上升2好，所以不好意思。然后我们要把它拖回来嘛，今天我说做上升2号，我们就来做上升2号，没有什么商讨的余地。对，虽然是可以去很远的上升2号，然后前面因为要救人，是要装小夹子，对，小夹子。然后 hatch 记得是在这里，所以我们需要。我们还需要一个气闸舱。气闸舱是在哪里啊？有一个小小的气闸舱，可是就不知道它在哪。上升2号的气闸舱在哪？哦，这个应该这样装吧？我装上去。啊，旁边还可以关东西耶，好酷哦！要这样子好了，然后这个 docking OK 是 open close 不大，太大了 open 好，它不够大。Okay, let's see. So, what other things do we need to? Well, normally we're not going to use like reaction wheel, but no, today, well, we need. So let's see. What needs to? Well, let's see. Of course, we need a lot of. Do we stage it out or we can't? I think we can't. Do we? Yeah, we cannot separate it. That's a problem. So, I'll deal with it, whatever. I just call it a day. And then says that I need to grab them back, so... Alright, what should I do? It's going to work like this. So, let's see. Coupling. Come on, can I do this? Oh yeah, I can do this. And then... Okay, let's move it inside. Let's move it inside the... Why the heck is not working? Okay. Let's move it inside. Okay, I think it's gonna work. Well, deal with it. I'll call it a day. I'll call it a day. So, yeah. Then we need a reaction wheel. Reaction wheel. I mean, how hard can building... can it be building, space vessel, proper space program? It should not be that hard. So, let's see. First we need a fuel tank like this. And then, well, another one like this. That's a little bit too... probably use like this one. Well, so ugly. So... oh, that makes sense, that makes sense. Let's just do this. And I need to hide this one, so I'll just hide it. No? Yep, yep, yep. Oh, we also need a... separator. So... the coupler here. The coupler... here it is. Now we also need a lot of RCS tank. Because we are moving a lot of things. So the RCS tank... should I add engine first? We're going to move a lot of things, so... well, definitely it's going to be a weird way. But it's gonna work. So... again, I'll call it a day, even though it's weird. Probably not. What could I do? I mean, I need to deorbit it, but it's a little bit... alright, I'll just call it a day. I'll just call it a day. And the RCS tanks.新希望殖民地这个，所以你们需要这个小球球，很多小球球，对，像这样子。我越来越难看了。Well, yeah, it makes sense, so I'll just call it a day. And of course, parachutes, a lot of parachutes. I'll add 4 parachutes, oh, it's not 8. Okay, 4 parachutes. I added probably here in bottom. Or on the top. I'm not quite sure. Okay, on top. And probably we'll need some EVA to place that. So we need more parachutes. And well, let's see. Probably we also need some air brake, but I don't think so. I don't think so. We only need parachutes. Yeah, parachutes. We only need parachutes. So I need cargo. Reload. Cargo. Is it going to be? Where's the cargo bay? Oh, here it is. It's too small and it's not going to work like... it's not going to be very elegant. So alright, I'll add one here. Just near the airlock. So, and parachutes. Where is parachute? Oh, it's not going to work. Dang it. Parachutes. How large could it be? Do I really use this one? Well, it's going to be very ugly. I mean, yeah, ugly, but well, still. Okay, okay, I'll do it. I'll do it. And parachutes. Eventually, I can put some parachute inside. Parachutes, 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 parachutes. Well, we don't need that much, to be honest. Why am I adding like this? What am I doing? Well, but it is the largest cargo bay we can use. That's a problem. Volume. Oh, no. We can use this one. So, here. And smaller cargo bay. I can put it here. Oh, how... It's going to be weird. Could I put it on here? I can put it on here, so it can also be separated. Yep, like this. So I'll rotate it to this angle. I hope it's going to work. In place. Okay, I call it a day. And then... No. Parachute. One. Only one. Dang it. Hmm, 1.2吨，还是可以拆上面的嘛，对不对？还是可以拆上面的。好吧，那就装就结束上吧。Okay, let's call it a day. Or watch up 2. And watch up 2 also need, a lot of antenna. So communication here. We can add antenna right here. So it's going to be like Soyuz like. Okay, sounds great. I'll add one here to make it more like a spacecraft. Probably here. Okay. And then turn the color to the color I love. No, to be honest, the real vessel is going to be like this. It should be silver, but I have no silver color here. That's a problem. It's fine, still going to work. So, okay. We also need power. So, electronics. Too much. Alright, fine. And then What kind of stuff should we need? Oh, the RCS nozzle. Oh, this vessel is going to be really weird. Okay. So here's our vessel. Oh, dang it, it's produced a lot. It's still enough. The only thing is we need to send this stuff to the moon. Yeah. So let's see. First, we need a propeller. I have a long time that I'm not rebuilding these Scrubbles programs. That's going to be a problem. But I think everything should be fine. Probably. So, payload. I think it's a little bit too long, but okay. 看起来绝对不像上升2号，不过好像也没办法了，就这样吧。这个方向长啦，真的是它太长了啦，是可以把它往上移一点点的。把它往上移也不犯法，对不对？好吧，还是不要乱做事。 它到底多长啊？这样不能用1.875的。啊，好吧，可以。想盖个上升2号怎么这么难？哦，因为就是要去月球上升2号，差点忘了这件事。 No, so we need to send this to the moon. So let's add more fuels and rockets here. Fuels. Okay, of course. Fuels. Fuel tank. This one. No. To be honest, this one. And engines. This one. Not perfect, but it's still going to work. So I'll call it a day. Or probably we can switch to. I'd love to use triple engine. So triple. Is it going to work? I'm not quite sure. Alright, I'll call it a day. I'll call it a day. Or probably I'll do... This makes more sense, huh? Move. Oh yeah, it makes more sense. And the only problem is how could we add... how could we add an adapter to connect with... deal with it. I'll use this trick. I'll use this trick. So coupling, no, payload, and Okay. Then move it inside. We are spending a lot of time in VAB. And then structural. No. Coupling. It is a little bit more expensive, but I'm not going to use it. I'm going to use it like. Thus. Where could I put it? Here? Okay, here. And then move it up to here. I think 2 should be fine. Yeah, 2. Like this. And put them together. Yeah, together like this. And it's going to work. Okay, so the only thing we need to do right now is send it to LKO. Yeah, LKO. It's not going to be that hard. Ted 既然说了，对，我们是要去月球接人的。不过我们要是想说先把它宣到地球轨道上，看看发生什么事。所以很不幸的是，我们又需要 fuel tank。对，就一节一节接上去吧。0.7这很明显不够，不过我们的丢套 P 好像也够，那就没什么大问题。coupling， 然后 fuel tank。为什么米儿觉得米儿每次做火箭都会做成那个样子啊？到底是为什么？为什么米儿做的火箭都会变成这个样子？到底是为什么？你也不懂呢。为什么米儿做的火箭会变成这个样子啊？看起来好像也还不错。那就好吧，再放4个会怎么样？虽然不好看啊，但是现在重点是能用就好啊。1008已经过剩了，而且这东西不符合我们的三幼的中心主义思想，所以说我们还是稍微改一下吧。如果这样子，你知道它这个名字就有0.22，不过它也烧太久了。好吧，不能用这个。有没有什么好的真空引擎我们能用的？例如它吗？对。本来现在重点是突出一个好看，那就 single 像这样，然后我们在旁边再，对，这样子。那不好看，这样真的不好看。上面果然还是得用白色的，然后 对，这才是我们要的 Kodiak 才对 Kodiak。好像有点太多了，那就这样吧。这种比4有点不太够，没错。This could be a problem, but let's see. Could I add like yeah, this support 1, 2, 3, 4. 1, 2, 3, 4. Here. Well, I think it's still not enough. Man, I want to use it, but the thrust is just not enough. Oh, deal with it. I want my rocket to look like this. So, 0.7. Well, that's still a lot of delta V. I mean, we are able to reach the orbit. Almost. So I think it should be fine. Yeah, it should be fine. So our rocket is going to be like this. Yeah, deal with it. I want my rocket to be like this. And it's going to be like this. But why every time my rocket looks like this? That's really a problem. I really need to... It's not quite... Okay, much more better. And of course... Not bad. Not bad. Not bad. 93这种是1.3 Not bad. So let's deal with it. And finally we can explain what's the hazard. What is the original proposal for this live stream? Okay. What? What? Oh, thank God it's not going to crash. Then what should I call this rocket? And yeah, we can add several cutie flag on it. It is 1 point, yeah. The diameter is like this. So medium and could I? No. Oh yeah, the power. I forgot to add the I think I forgot to add the solar panel. So yeah, where is the solar panel? Well, Watcher used to be supposedly not have a solar panel, but we need one. We actually need one. So let's see. I prefer this one. And just plug it onto... No. Alright, deal with it. I say it's going to work, so it's going to work. Yeah. Okay, let's go. Well, it needs to be any kind of launch, so let's go. Ah, 糟糕，忘了马钢琴了。Have you read Rockets and People by Boris Chitov? Well, not yet. I'm honest, so I would say no. I've not read it yet. But thanks for your recommendation. I will read it once I have time. It is totally not going to work in the real life. But it works in Kerbal Space Program, so I need to do it. And to be honest, let's do this trick. You know, the real Soyuz act like this. I mean, this is what the real R7 rockets is supposedly to look like. So not perfect. Oh, it looks so ugly. Hey. Alright, I'll call it a day. Okay. Save, and let's go. Well, 1.2, it's not going to be so... I'm not sure. Let's see. Oh, come on. I'm just going to launch it like this. And I'm not sure. Let's check about the sound. Yep. No, spacecraft 10%. Oh, reduced to 7%. Close. Hopefully it's not going to be a problem. Okay. 3, 2, 1. Let's go. Okay, here's the we have roll program, but this is not that kind of rocket. I would say what kind? Bicameral? We are having a roll program. Okay. I mean, how hard could it be? How hard could it be launching a rocket to low current orbit? Yeah, how hard could it be? We have met that. So let's discuss a bit about well, when it's launching. Of course, we are going to suffer some problem during the action phase, but that's not the business we are going to discuss today. 那不是我们今天要考虑的内容嘛？你就先看这个 R7，对，这个 R7 是它应该是，不知道怎么说的 R7 了，入轨吧。 这样它其实是有一个公司在的，你也有认识的人会算，可是反正就你也是不会算。这里是不是说不有鬼啊？那 booster 快烧完了，可是我们上面的这个东西又不够，感觉不太妙，说实话。5, 4, 3, 2, 1. Booster separation. Well, not that. It's going to work. And okay, let's deploy. Let's deploy it. Oh, a seal of our 7 rocket. It's so beautiful. But it's pulling down actually, so yeah, I'll twist it a little bit. Just a little bit, just a little bit, just a little bit. Oh, I'm gonna be launching a rocket to low current orbit. Yep. Well, I imagine it's not going to work, probably. So, disengage. Let's see.哎，现在你说那个我有看到，我有看到。他真的是，他居然能飘，我们讶异的。So let's see. Okay, we're going to restart it. Oh.还是挺不错的嘛。Okay, so let's just let it surrounding the curtain, and eventually you can start to talk about, hazard in the space. So, like, we talked about major hazard. So, let's deal with it. I mean, space looks beautiful, right? But it's also very, dangerous. So, let's see why is it dangerous in space? Yeah, why is it dangerous in space? First, we're talking about vacuum. Right? Vacuum. So we need a capsule we need a capsule like this. We need a capsule to make sure it's not a vacuum inside. But the atmosphere condition of the capsule is actually very worse to deal with. I'll probably explain it later, probably. I mean, it's not going. You don't need the exact same atmosphere as you have on the ground. So yeah, but it could not be a vacuum or you're going to die. So The harder of space is first it's vacuum, and then it is thermal extremes. It also happens in Kerbal Space Program, but you know that the space is very hot and very cold. So it's like if it's exposing in the sun, it should be like several hundred of Celsius, and if it's just in the shadow, well, it could be like minus several hundred degrees, not several, 100 more degrees, and well, your capsule needs to protect it from this extreme temperature. That's another hazard. And also, microgravity. Why are we talking about microgravity? It is because, well, we all know that, well, microgravity, one thing is that gravity is, well, that's inflated. Oh, goodbye. Open. Okay. Oh, how cute it is. Could I transfer crew to transfer? Okay. And then EVA. Okay. So let's see. When we talk about microgravity, oh, well, first, of course, microgravity is it's harmful for long term. If you are an astronaut or cosmonaut or taikonaut, well, I love the reflection. See, there's you can see the vessel on the helmet. Yeah, on the helmet. Yeah, but I still I love her face. I'll just do this. Well, first, microgravity is going to be harmful for the astronaut, of course. 这个微重力会对太空人不好影响嘛？那其实有另外一个东西，就是我们刚好提到热，有热，还有散热。那散热为什么呢？因为，就知道对流传导辐射嘛。那太空中因为没有重力，就没有办法热空气上升、冷空气下，因为就没有重力，所以说那个对流散热会。它其实量很多，就是在几乎零重力的环境下，对流靠空气对流的散热效率会降到在地表的大概3%左右，就是东西几乎没有办法靠对流来散热。如果你在太空中看到一个热水壶，你就会看到，热水壶在加热旁边的空气，然后因为热空气不会上升，冷空气没有办法过来补充，那你就会看到，它周围逐渐形成一片热空气。然后空气又是热的不良导体嘛，所以就散不掉。所以那个 we're talking about convection. Because of the microgravity, the hot air cannot absent and the cold air incomes. So the efficiency of convection cooling will reduce to about 3% comparing with the surface of the Earth. And it's going to be a problem if there's any equipment inside the capsule, and it needs to be cool. So, I mean, even the astronauts themselves are going to be harmed by microgravity. It's like trying to imagine like you are doing sport in the space station, and because of the lack of the convection, you're going to overheat because you can feel that okay, the hot air is surrounding you and it cannot go anywhere, so you're actually heating, and eventually you're actually surrounding with hot air and you're going to like it's too hot. And also micrometeors and orbital debris. Well, here's Kerbal Space Program, so it's not going to be a problem. There's no orbital debris, but in the real world, yes. And we also have like micro meteorites. So they will cause some like impact. 就是太空中的这些残骸，如果你们有看过地心引力，地心引力就好骗，但是就没有什么39，反正就地心引力嘛。就太空垃圾的危害，这个地心引力里面讲的也蛮清楚的。然后那个微陨石也会去撞太空船，那它们会造成一些 就是 impact 或者 penetration， 当然希望不要 penetration 啊，但是如果你遇到了，他们一定会 impact 嘛。那这要怎么解决呢 ？Well, you need to discuss about material design and orbital selection and choose the correct attitude that you are not going to encounter。就是说，如果我们确定所有的太空垃圾都在这个高度的话，我们就不要到那个高度的轨道。那如果真的会遇到的话，就是太空船的什么材料设计，还有我们选择的轨道，都会影响到我们遇到它的几率。说了嘛，那个这是 hazard， 它不一定会发生，但是它有可能会发生。然后再来就是之前 I think I mentioned it well from the last live stream. Yeah, the last live stream. Let's back. I think I mentioned it on the last live stream. It's about radiation. Why can't I? Oh, I see. Transfer crew. Transfer here. Okay. I just find that I cannot use the full node, but it's fine, it's fine, it's fine. Hey, she's pilot. Why can't she use it? I don't know. But still visit. Still going to work.大部分的管理其实也真的蛮重要的，像在坎巴，就是你要定期的去 tracking station 清理残骸。如果你不清的话，事情就会很大条。就是现实世界中，你没有办法直接在那个 space center 里面把这些残骸炸光光，那问题就会更严重。Okay, let's see. To the moon. What can I say? We choose to go to the moon. Yeah, we choose to go to the moon, of course. For several reasons. Or could I just say, we choose to go to the moon because we can. Well, history doesn't work like that. I should use the reaction control system. I have a lot of moral propellant. Okay, let's see. Normally they will let the third stage to impact with a lunar surface like this. So I'll do the same trick. To avoid, well, you know, the... What's that? Oh, I want to also add some inclination to avoid it actually impact with bouncing on the crater area. So like this one. Okay, we have some inclination. No. Going to let me like this. Come on. 好漂亮的杆球啊，很漂亮，但是危险啊。能说什么呢？Isni sanam niru kat kasma duma. Okay, let's just separate it. To avoid us just impact directly to the lunar surface. And why can't this R7 style Soyuz go to the moon? Why? I'm quite sure, but it's going to happen. Okay, so we talk about vacuum and microgravity and thermal, and these are actually something other things we need to deal with because we are leaving Kerbin, or I would say the Earth. So first, talk about radiation. And if you watch my last live stream, 如果你上次看过米安的直播，就上一次啦，就是米安有讲过那个几种不同的辐射类型，就是SP 跟 GCR， 一个是太阳的粒子，一个是宇宙来的粒子。Well, if you talk about if you ever watch if you watched my last live stream, I mentioned about different radiation types in the space. One is GCR, galactic cosmic rays. Another is solar particle event, or SPE. And I talked about how to block them or prevent them to affect the spacecraft and the astronaut. I mean, those radiation are dangerous not only on human body but also on the avionic of the capsule. Like some bit in the computer will flip. Yeah, will flip. 就有一些什么单位位元翻转之类的事件，会因为宇宙射线产生错误。你要记得，就是有一次，好像亚利安的火箭的首飞就是因为这样子砸掉的。是这样子嘛？就是那个宇宙射线打到一些晶片，然后晶片就出错了，这样子就是会有这种事情发生。因为我 What's that? Electronic single event update, SEU. We call it SEU. So to deal with the radiation, we need better characterization, prediction. We need to 至少我们要知道我们会遇到什么样的辐射 and also shielding. Shielding. Are you some magnetic field or electric field to protect them? Well, I would still say like water and what's that? It should be F what? Ethylene, yep, ethylene are the great material for blocking the GCR. And also, because we are leaving the protection of the magnetic field of Kerbin, because you can see we have aurora here. To be honest, even any kind of orbit passing through the polar area, like this satellite, it needs to deal with the radiation come from top and down, because we are the radiation of the polar area is still stronger than the radiation on the equator area. 就是说，如果卫星是绕极的，它经过南极跟北极，那在这段时间，卫星或者说如果有人的话，他们都会扑在比较强的辐射底下。那再来就是那个很重要的东西，就是 plasma， 就是电浆。 那这个比较有趣的部分，就是说，其实这块是多少？我要找一下 radiation。另外一个重点是那个什么来着？plasma， 对，这个其实蛮有趣的，就是这是你也觉得有趣的部分，就是电浆这个部分其实是反而是在坎球附近才会遇到的事情哈。就该怎么说？plasma will cause charge， 就是电荷的累积啦。那这点蛮有趣的一点就是说，就是大家知道大气层并不是到太空会完全真空，还是会有一点点的气体。那气体这个东西在越高的高空就越容易被电离。I mean, the atmosphere is not totally vacuum; it is almost vacuum, but still a little bit, only a little bit atmosphere. In the low orbit, and we all know that the molecules of atmosphere will be ionized by the radiation of the sun or mainly from the sun. So, because they are ion, it will cause charge. 就是说这些被电离的气体，其实就是电浆啦。其实这些很细薄的电浆，其实会在那个低地轨道的飞行器上面累积电荷，就是 charge 的意思。那如果是没有太阳能板的东西，在地球轨道绕的时候呢，大概最高就会大概会产生1伏特左右的电位。但是如果它有装太阳能板，因为太阳能板很大片，它可以累积很多的电荷，那就需要去注意，就是你装太阳能板越多越大片，它越容易累积电荷。所以如果你装太阳能板够多的时候，你就要考虑这些电浆造成的电荷累积会不会造成出事。So try to image like it is charging the whole spacecraft, so it will cause static electricities. It happens in somewhere and during the winter. Just try to image that. If the orbit is higher, it can accumulate to several thousand volts, and the density of the plasma is actually reducing with the altitude. So if it is higher, you will encounter more plasma, unless you are far enough to the deep space. But the deep space still have several charge. So how would these plasma affect? Try to imagine like you are EVA, you are the astronaut, and you are leaving the vessel, or you are docking your vessel with other spacecraft, and because you have been charged by the plasma, and boom, you will got shocked. 就是大家有没有那种被静电电到的经验呢？如果你的航天器、太空船随便拿被电浆充电充过头的话，那你在出舱或者是跟别人对接的时候，可能就会被静电电到。那这可不是一件什么好事。那像前面有提到，我觉得像空间站和太空站就需要处理这些东西。So how would we deal with it? Well, we can use like we need to mitigate the effect of the charge. So we can like use some what's that? Rods or whatever, some metal spike to discharge your spacecraft, like connect with the ground. 如果接地就是如果有静电，就需要接地嘛，对不对？都需要接地。那接地的话，就会遇到一个问题。太空中没有地可以接地，你看地在那边，我们要怎么接 ？So how do ISS deal with it? Well, ISS actually exhausts gas. Well, they storage xenon gas on the assets and exhausting the gas to displace the charge. 它其实在那个国际太空车上面有装氙气，就是电推用的那个氙气，然后靠排放氙气来降低这些电荷的影响。好，那我们讲完了，我们就可以去问了。也蛮近的，就一下要到这样子。然后我们这个可怜的第3节就会这样直接砸上去，反正不关我们的事。然后砸在，它应该不会砸在殖民地上啊，不是月表基地上，什么殖民地 ？Okay, let's see. So who are we going to rescue? Who? I mean, it said that we need to rescue one Herman. No, not this one. Wait, did I actually rescue? Oh, dang it, it's... Did I actually... Alright, I need to deal with it. Space Center. That's a lot of problem. Loading and mission control and... Oh yeah, that's a problem. That's a problem. Rescue. Oh, too many rescue. Too many crews here. I mean, oh yeah. Thankfully, it's KSP program, not Mars Horizon, or otherwise I need to pay the salary to those crewmen. And let's see, now we can see... What? 之前登月上海70吨的车子被老板看怎么说？70吨真的有点太重了呀！70吨呢？省点重量吧，火箭是很辛苦的。Okay, here's our watch up too. So where is that? Oh, I see. There's target. Not bad, not bad. Not bad. What we need to do is just... right here. It's close enough. So let's see.我是有点负的俯角，所以要 normal。在那边 Gura， 当时名字随便取就变成 R 了。 just casually pick up a name and it's... Okay. So then we need to walk here to... Well, let's see. We are here, so... No, it's not gonna work. Let's do the next warp. Well, we need to like, okay, spinning. We're almost there, We just need several more maneuver, like... No... What is it going to work? I don't know. Oh, shoot. Oh, come on. Alright, deal with it, I'll do it again. No? Oh, yeah, it's close enough. So... What I need to do is... Let's see. What? It's not working. I don't know. I don't know why. It's supposed to work. I am here, and he's a little bit. So I should do like this. Oh, it's working. So okay. Let's do it. So warp to... Oh, here's another problem. I cannot... punch to the target. That's going to be a problem. Shoot. Shoot, it's not going to... Okay. So... it requires my personal skill on docking. Dang it. Let's see. Come on, watch out. You can do it. I feel like peeing off. Arm control from here.所以这边为什么会有飞机的机头啊？I think it's stable enough, so I just do this. The only problem is why there's a cockpit here. Ah, no.抓住他啦！讨厌呢！啊，找到了，然后就好了 ，transfer crew 到这里来，然后我们可以让小绿人做一点 EVA 的工作，在上面至少绑一个降落伞，然后像这样子。然后它可以在这边，它应该要，no。Oh, it's pilot, so I can't. Ah. Oh. Do we have engineer here? Scientist, no. Okay, let's just call it a day. Okay. 不是工程师没有办法用，太久没玩都忘记这件事情啊。算了，就这样子，我们回去吧。反正它应该烧不坏啦，有4个降落伞。So let's see. Let's go home. Go back to carbon. That's great. We're not facing a lot of problem. 但是这个看起来像我charge的东西，居然能够一路跑到这边，那怎么想都很奇怪啊！我charge联盟本来就是负责登月的东西嘛。其实太空船着陆也是一个需要设计的东西，不过不是今天要讨论的范畴啦，所以就这样子吧。Just call it a day. And let's see. F5. And we can go back. Well, since we are full charge, actually we can separate several things. So, first, it's our this stage probably. Okay, stage. Bye. Probably we should not stage this first. And then it's the airlock. Okay. It looks so weird now. Okay, we are in the atmosphere. Everything's overheating, of course. I don't care. We need such things. So here it is. Well, I just want to discuss what the hazardous stuff in the Spice Everyone. I don't think I should do this mission, but yeah. What's wrong with this one? I don't know. Well, it's not on charge, so it's fine. And we are falling. What's that? Experimental engineering. Oh, we still have this tiny antenna. How about we just deploy it to generate some beep? you can see, this is the unrealistic stuff in Carlos Boost program. The stream of parachute is passing through each.如果一个降落伞就够了嘛？真的是，它还是歪的。And that's it. Well, it's not designed to splash down the water, but we'll deal with it. We still have like one, you know, the cockpit and recover vessel. I think that's all. 2.5 hours. Not bad. But I think I need to apologize for the board topic probably in this live stream. I don't need to apologize, but for me it's a little bit fun. I mean, try to learn the real world experience, like how it's going to work in the real world. 44 is not definitely nice, so okay, probably. Oh, it's expired, so okay. There's no rescue mission. And that's it. Apologies for the boring topic today. But hey, sometimes the real world experience is fun, right? 就这些东西嘛，都是卡巴里面没有听过的东西，但是至少在现实生活中，它在游戏里不存在，不对吧？它在现实生活中不存在嘛。但在游戏里面认真就输了，可是不该怎么说呢？可能卡巴就是一款能够让人这么认真的游戏吧。And let's see，视频把我的降落伞就确了，还是让你不要这样子。你是希望你的每一个小绿人都跟科马洛夫一样，是不是？今天小绿人冲到环开赛，你们就这么想？那你还讲一下那个双子星计划使用的降落方式好了，这也蛮有意思的。不过先这样子好，就我们谈了太空中一些常见的危害，还有到底该怎么设计那个一个太空任务。虽然过程感觉非常的像是在上课，不过就这样吧。你要是快速的把这些东西讲得更有趣一点，但是说实话不敢保证。那今天就先这样子。Well, I think that's all the content of today's live stream, and thanks my sweet, and again, well, good morning, good afternoon, good night. I don't know where you are, but wish you have a nice day. For me, it's 5 p.m. No, it's 5 a.m. So I'm probably gonna rest and get to sleep very soon. So I will say good night and wish you, what should I say? Have a nice weekend. Yep, enjoy. Bye.